Hi everyone, welcome to the lecture series on computer architecture and organization. This is our 8th lecture. In this, we are going to see the continuation of the previous lecture, that is the instruction set. So this is instruction. Before getting into the instruction set, the memory organization is also associated with this instruction set. So if you see the memory organization, as we have discussed that the memory may also include data. Not only the registers holds the data, the memory also includes the data which are less used, and we call this as the spilling registers. The memories are called as spilling registers sometimes if it holds the data that is involved in the program. So it is viewed as a very large single dimension array with access by address, and the memory address is an index into the memory array. And this byte addressing actually, inside the memory the data are stored in words, that is 32 bits. If we go for byte addressing, the index points to a byte of a memory. So what is byte? In the sense, it is of 8 bits. Okay, so byte addressing means that the index points to a byte of memory, and that the unit of memory accessed by a load or store instruction is a byte. Okay, so 8 bits of data we are accessing. If we access the 8 bits of data, then it is called as byte addressing. And if we access all the 32 bits of data in a register, then it is called as word addressing. Normally we are using the byte addressing inside our course. Okay, so this bytes are nothing but the load or store units. Most data items use large words. For MIPS it is a word is a 32 bit or 4 bytes. Okay, so if we address the memory, see here, if we address the memory, the address is not sequential, that is 0 1 2 3. It is 0, it is 0, and it is 4, and it is 8, and it is 12. So likewise it goes, because the 32 divided by 4 gives 8, that is 1 byte. Okay, so inside this, that is 0th byte, in 0th byte, and that of this first byte, second byte, and third byte. So 8 8 8 and 8, which is equal to 32. Okay, so 32 bits. So likewise, so it has 0 to 3. It has 0 to 3, 0 to 3, and the next is 4 to 4 5 6 7, and the next is from 8 9 10 and 11. So next is from 12 13 14 and 15. Likewise it goes. So this 2 power 32 bytes with byte addresses from 0 to 2 power 32 minus 1. If it is the case of 2 power 30 words, then the byte addresses will be from 048 up to 2 power 32 minus 4. That is, the words are aligned here. Okay, so next, coming to the point of this load and store instructions. What is the usage of this load and store instructions? In the sense, the processor can hold a limited data on the register, whereas it can place more number of data on memory. Or we can say the less used data are often placed in memory, and sometimes memory are referred as spill registers if we place this less used data. So load and store instructions are used to access the memory in order to fetch the data or in order to write the data. So see here, this example has both load and store instructions. The C code is array of 8 is equal to H plus array of 8. So the compiler converts this C code into MIPS code. So the first is we need to load the instructions. Okay, load the word. So load word has the destination first, and the stored word has the destination last. Okay, so load word has the destination first. So what we need to do, so this expression says the array of there is an array. We need to fetch the element 8 from the array, and that element should be added with the value h, and again it should be saved in the same place, that is the element 8th of the array. So what is the first line is that we need to load the word. So we need to fetch the data, that is, we need to fetch the data from the memory. So in order to do that, we need to address that. So how can we address is that we need to add two space we need to add two things. One is the offset is nothing but which element or which data. So it is of 8. Since this MIPS comes under this byte addressing, that is every 32 bit is divided into 8 bits. So a of 8 in the sense it is 8 into 4, so that is the offset is 32, and the 32, and we need to specify the starting address of the array. So here we have assumed that the starting address of the array is in the register $S3, is in the register S3. See here, it is in register $S3. So if we want to represent a memory space, then we need to provide the offset as well as the starting address of the array. The starting address of the array will be in a register. We need to specify the offset along with this register address. So this a constant is called the offset, and the starting address of the array which is in the register, which is called as the base register. So 32 of $S3, we have fetched the data, and we need to fetch the data and we need to place it in a register, because all the instructions in MIPS are taking place only in the register. Everything cannot take place in memory. So that is the restrictive use of this MIPS. So we need to transfer this data into a temporary register, that is $T0. Now this is in $T0. Okay, this is in $T0, that is a of 8 is in $T0. Now we need to add this a of T0 with the value of h. We have assumed that $H is in the register $S2. So now what happens? This a of 8 is in $T0 and this h value is in $S2, and again we need to add both these things, and where we need to kept in the destination address, that is $T0, that is a of 8. Okay, so $S2 is one of the source register and $T0 is the second source register. We need to add these two and we need to place this in $T0. Okay, and what is the example for the store instruction? Store instruction has the destination lost. So what we need to do, again if we want to place this in a memory, the sum should be placed, the sum is in $T0, but where it is kept, it is in a of 8, which is in memory. So we need to denote an address. So add this $T0 should be placed in the memory. So the store word instruction has the destination lost. So $T0 is nothing but the added value or the sum, and the sum is placed in 32 of $S3, which is the address of the memory. Okay, so let me explain this again. This code is written in C. So that is a of 8. So this is the array of 8, that is the element 8 is equal to h plus a of 8. So compiler, in between these two, the compiler acts. So this compiler converts this C code into the MIPS code. So MIPS code only operates, the operations takes place only on registers, not on memory. So what we need to do is that first we need to take this value from the memory and we need to keep this in a temporary register. Okay, so how can we denote this a of 8 in MIPS? How it will take, how the MIPS will take, how the computer architecture will take this MIPS code, in the sense it is provided with an offset along with the address. So offset in the sense which data we need to, which element we need to fetch. So it is 8 in the sense we are dealing with the byte addressing. So byte addressing, MIPS has 32 registers. If a word 32 bits, 32 registers, also it has, each register is of 32 bit. So this 32 bit is divided into 8 bits, and these 8 bits are termed as one address. So this 8 bits are termed as one address. So for in a 32 bit, if we can split, we can take this as 4 registers. Okay, so 4 byte addressing. So 4 byte addressing in the sense we need to take the first 4, that is 0 to 3, and from 4, 5, 6, 4 to 7, and from 8 to 11, likewise it goes on. So what is this element 8? Element 8 will be in the location 8 into 4, okay, so which is equal to 32. So we need to fetch the data from data of the element that is 32. So this constant value is called as offset. And where this 32 will be, it will be in some space or it will be in address. So the starting address of the array, we are not giving the address of the element that is placed. The starting address of the array in a register, which we have assumed that it is in $S3. So this address is called the base register address, okay. So this base register along with the constant value or the offset value, which we are going to fetch the element from the memory space, and this provides the memory address. So from this we are fetching the element and we are placing this in a temporary register, which is $T0. So now this A of 8 and $T0, we need to add the value h. We have assumed that this value in $S2. So we need to add the contents of $S2 register and $T0 register, and again we need to place this in a temporary register, okay. So we are placing this in $T0 register. So now the sum is in $T0 register. Now we want to again store the data in the same memory space from where we have fetched the memory data, or we can say that we are rewriting that place, okay. So now we want to store that word. Store has the destination lost, so the result of $T0 is placed in the memory space or the memory address that is denoted as 32 of $S3. So far we have learned that MIPS loading words but addressing bytes. We are loading the words but we are addressing in bytes. So the words are nothing but the 32 bits, and the byte addressing in the sense we are taking the address only in 8 bits, and the arithmetic operations can happen only on registers, not on the memory space. So let us see here what are all the instructions and its meaning. So instructions and its meaning, if you want to add it, the MIPS has only 3 operands, okay. So here if you see in the add instruction, it is source register. These two are source registers, and the content of these two registers are added and put it in the destination registers, that is $S1. Similarly $S2 and $S3 $S2 and $S3 are the source and destination registers, and the values are need to be subtracted and it should be placed in $S1. And if you see the load instruction, what we need to do is that we need to load the content of the memory address. How can we provide the memory address? Here we have provided the base register. This is called as the base register, or the register at which the data, and we need to fetch the constant 100 or the offset. We need to represent the offset. So the sum of this $S2 register along with this offset provides the memory address. So that content of that particular memory should be loaded into $S1 register. Similarly, the memory of the $S2 register plus 100. $S2 register holds the starting address of the array, which is called as the base register, plus the 100th element. So 100th element in the array, that gives the memory, and that memory location data is stored in $S1 register, okay. So what is this machine language? Instructions like registers and words of data are also 32 bits long. And in this MIPS, what happens is that it assigns some numerical value to the registers. So nothing but the registers are numbered. For example, here there is an instruction which is called as add $T0 comma $S1 and $S2. In this $S1 and $S2, the contents of both the registers get added and it is placed in the destination register $T0. So what does this MIPS does is that it assigns some numerical value to the registers. So here $T0 is assigned a value 8, and $S1 is assigned 17, and $S2 is assigned 18. Okay, let us call this arithmetic instructions as R-type instruction format. So R-type instruction, we are splitting the whole word into 6 parts. Okay, the first part, or which we are calling this as a field. Every part is called as field. The first field has 6 bits, and the second field 5, and the third bit 5, fourth 5, fifth 5, and sixth as 6 bits. So totally there will be 32 bits. First field represents the operation code, or what operation we are performing, like add, sub, and load, store, etc. And the second is the first source operand register, and the third field is second register source operand, and the fourth one is the destination register, which is represented as RD, and the fifth field is shift amount, which we are not using right now, and the last field is function field that selects the variance of operation. So that's all for now. Let us see the remaining in the next lecture. Thank you.